Okay, let's make this a good reference that we can put into our notebook so we can see the transformations. That's why this is called the Transformers task. We can see the transformations of this parabola. So we're looking here in the first section of 4 different tables, and we're watching for the change. What happens here when I add 5 to the parent graph of the parabola? What happens here when I add 2? What happens here when I subtract 3, when I subtract 5? And then we're going to summarize that change down in the bottom of the graph. So like I said, this original graph right here, this is the parent graph of our parabola, which we now know is the equation y equals x squared. That starts at the origin and grows at a typical growth rate, an a value of 1. And this is what the graph looks like. So let's go see what these tables show us as the change. So starting with the plus 5 graph. Let's go plug in some values and see what happens. We're plugging in a negative 2 right here. Negative 2 squared plus 5. I'm actually going to show the work on the side. Negative times negative is positive 4 plus 5. That would be 9. Next, let's do the negative 1 squared plus 5. 1 times 1 is 1, plus 5 would make 6. 0 squared plus 5. 0 plus 5 would be 5. And notice this constant value right here. There's my 0 term. 1 squared plus 5. 1 plus 5 is 6. 2 squared plus 5 is 9. And 3 squared plus 5 is 14. Do you see that symmetry that started to occur there? So now we're going to go put that graph, negative 2, 9, negative 1, 6, 0, 5, 1, 6, and 2, 9. And so we see that the original parabola was moved up 5 based on the plus 5 at the end. Let's go do the next one. Notice here for this one that I've got a plus 2. And we also are starting to recognize that that's going to be my 0 term. 0 squared plus 2 is just going to be 2. So let's go plug in the values. Negative 2 squared is 4. 4 plus 2. Negative 1 squared is 1 plus 2. 1 squared is 1 plus 2. 4 plus 2. 9 plus 2. Let's go graph the purple graph. Back 2 up 6. Back 1 up 3. 0, 2. 1, 3. And 2, 6. Check out that graph compared to the original. Do you see it's just moved up 2? All right, for the next one, we're now seeing a change of a down 3, a minus 3. Let's go see what happens. Negative 2 squared is 4. 4 minus 3 is 1. Negative 1 squared is 1. 1 minus 3 is negative 2. We're getting into some negatives here. 0 squared is 0. 0 minus 3. There's my 0 term, my y-intercept. 1 squared is 1. 1 minus 3. 2 squared is 4. 4 minus 3 is 1. 3 squared is 9. 9 minus 3 is 6. Let's go graph the pink graph. Negative 2, 1. Negative 1, negative 2. 0, negative 3. And then look for those symmetrical points. Check out this pink graph. Oh, that was a bad line. In relation to the other graph. Notice that it's been shifted down 3 from the original. Finally, I'm going to go make the last graph as gold. Negative 2 squared is 4. 4 minus 5 is negative 1. Negative 1 squared is 1. 1 minus 5 is negative 4. 0, negative 5. There's my 0 term. 1 squared minus 5 is 1 minus 5 is negative 4. 2 squared is 4. 4 minus 5 is negative 1. 3 squared is 9. Let's go put those dots on the graph with gold this time. Negative 2, negative 1. Negative 1, negative 4. 0, negative 5. And then the 2 symmetrical dots on the other side. There's also a 3. It's out there. Okay, when you're done here, you can see all these different transformations up and down. You should have the original parent graph hopefully highlighted, and then 4 different color graphs from the 4 different tables. Let's summarize this change over here. What just happened? We notice that when you add or subtract a constant at the end, it moves the graph up and down. What is this called? This is called the horizontal shift. The vertical shift, up or down. Okay, so anytime we see a constant at the end like that, now we're going to start to recognize that potential shift. Let's go look at the next 4 tables and the next one. Again, you're going to highlight that original parent graph. I'm going to go use the same color blue. There's my y equals x squared graph. Let's go see what these changes do. So plugging in negative 2 plus 2, do you see how that's going to zero out? That becomes 0 squared, which is just 0. Negative 1 plus 2, that's going to become 1. 1 squared is just 1. 0 plus 2, that becomes 2 squared or 4. 1 plus 2 is 3. 3 squared is 9. 2 plus 2, 4 squared, 16. And then 3 plus 2 is 5. 5 squared is 25. Let's go put some dots on this red graph. So now I'm going to go back to 0, negative 1, 1, 0, 4, 1, 9, and then I can't even fit the other ones on there. So what this just made is half a parabola. Let's go put the other symmetrical points on each of the other sides. So check out, if there's one here, there's going to be one here. And if there's one here, 1, 2, 1, 2, there's going to be one here. And finally up at 9. Go ahead and connect your red graph. This time we notice that the original blue parent graph moved left. So I'm going to put a little comment up here that this moved left. 2. Interesting. An x plus 2 shift moved left. Okay, what color did I use next? I used purple next. For the second table, we're plugging in negative 2 minus 2. That's going to be negative 4 squared is 16. Negative 1 minus 2. That's negative 3 squared is 9. 0 minus 2. That's negative 2 squared, which is 4. 1 minus 2 becomes negative 1 squared, which is 1. 2 minus 2 is 0. 0 squared. 3 minus 2 is 1. 1 squared is 1. We did see a little bit of symmetry on this one. Let's go graph the purple graph. Back 2, up 16. Oh, it doesn't even fit on my graph. Back 1, up 9, up 0, 4, up 0, 4, 1, 1, 2, 0, and 3, 1. And let's go put some symmetrical dots. We're going to 4. Oh, I don't even have 4. But we know that we could go up and find the symmetry here. And then we could go right here for 5 all the way up to 9. So that purple graph, we notice shift right to. Look at the original origin dot and look how it shifted. Okay, what color did I use next? Next I used pink. Okay, for this one it's an x plus 5 shift. Notice it's in the parentheses with the x as well. So we're going negative 2 plus 5 squared. That'd be 3 squared, which is 9. Negative 1 plus 5 squared, which is 4 squared, 16. 0 plus 5 squared is 5 squared. 1 plus 5 squared, 6 squared is 36. 2 plus 5 squared, 7 squared is 49. And you can see the next one coming. 8 squared is 64. Let's go put whatever dots fit on here. Negative 2, 9 would be right here. Negative 1, 16 is going to be way up there. So honestly, to show you guys this one, I sort of need to do some more dots in a different direction, don't I? So negative 2, 9 is right there. But we need to go like negative 3 plus 5, which is going to be 2 squared, which is 4. So I'm going to go negative 3 and up 1, 2, 3, 4. Then it would end up as negative 4 plus 5 is 1 squared. So negative 4, 1. And then negative 5 plus 5 would be 0 squared, which is 0. And then go ahead and make those symmetrical spots. And then connect that pink graph. We notice that an x plus 5 shift is actually going to be moving my graph on from the origin left 5. Okay, last one is x minus 6 squared. Without even doing the table, can you envision that a minus 6 shift is going to shift right 6? Take your original origin and go 1, 2, 3, 4, 5, 6. But let's go get some dots on the table and see what happens. Here we've got negative 2 minus 6, which is negative 8 squared, or 64. Negative 1 minus 6 is negative 7 squared, 49. 0 minus 6 is going to be negative 6 squared, or 36. 1 minus 6, 25. 2 minus 6, 4 times 4 is 16. 3 minus 6, 3 squared is 9. I'm going to keep this table going down. 4 minus 6, 2 squared is 4. 5 minus 6, 1 squared is 1. 6 minus 6, 0 squared is 0. So let's go put those dots on. If I go 4, 4, 1, 2, 3, 4, it's going to be a dot there. If I go 3, 9, there it is right there. If I go 5, 1, there's that dot in there. Now go make the symmetrical ones on the other side. Boom. Oops. Did you see what I did wrong there? It needs to go one more out. And then it needs to go up to here. Hopefully your parabola looks prettier than mine. That one's pretty bad. Let's redo that. Okay, hang on. Okay, let's try this one more time. Okay, there we go. So you've got 4 tables. We've got the original parent graph and the 4 shifts. How could I summarize what happened with that one? We noticed that when we added or subtracted a number to the x, in the parentheses, it moved the graph left or right. Okay, so looking up here, we had a movement up or down. Now looking down here, we had a movement left or right. So this one's called the horizontal shift. And that moves your graph left or right.